Hi, I'm John Merritt, Director of Applications Engineering at Ideal Power. Today, Mike Barron, Senior Firmware Engineer, and myself will be demonstrating the advanced microgrid features of our 30 kilowatt Stabiliti multiport power converter. All of our demos were recorded in Ideal's Research and Development Lab located in Austin, Texas. The 30C3 converter has a 3-wire, 3-phase, 480 volt AC power port and 2 DC power ports, enabling high-efficiency solar and storage microgrids in one compact enclosure, which weighs about 140 pounds. Multiple 30C3s may be paralleled to support larger microgrid applications. Our demo setup utilizes 4 30C3s in 120 kVA nameplate configuration. Our previous demos were all about microgrids that were battery-only microgrids. And while that's interesting, that's not what we believe represents the real opportunity for products like this. This is a multi-port product, which means that it's got a means of connecting solar right next to where we connect the battery. And so in this case, we're going to demonstrate solar and storage integration. We have a solar simulator that's being used by the other half of our lab, so we're going to do something clever. We're going to go to a 1-box microgrid, unit number 1, and it's supporting a 16 kilowatt real load right now. So this is a single unit microgrid. And this is the unit that we're going to be spending most of our time with. Number 2, though, is we're going to turn on in a special mode. It is a solar simulator. So we're going to use 2 as basically a surrogate sun to deliver power to number 1. And then we're going to walk through some modes of operation with what can we do with that solar power. So even though you'll see 2 lit up, and it is lit up now, the real focus is on what we do with number 1. So we're going to proceed as follows. We've got the ability for that sun to produce 5 or 10 or 15 kilowatts, or even more, as much as 20 or 30. And we'll show how power flows occur in the system. As we turn the sun on, and we ask for 5 kilowatts from the sun, that's 5 kilowatts that the battery no longer has to deliver. So the battery load will drop from 16 to 11. Then we can ask the sun to give us 10 kilowatts, and we'll drop to 6 kilowatts, and so forth. And in fact, we can reverse flows. We can have the sun provide so much power that it will power the microgrid and charge the battery simultaneously. So all those flows are interesting, but probably the most interesting flow to me is the last one, where I adjust the solar contribution to exactly the load of the microgrid, in this case 16 kilowatts. I can run this thing completely from the sun, only sipping on the battery when a cloud comes over. So even though you have a really bright sun, you're using the battery in a more aggressive way than we do, and that's what Mike will be demonstrating here. So first we're going to introduce the solar component in 5 kilowatt increments and demonstrate that, and then he's going to basically take a very fine knob here and have the sun's contribution pretty much exactly match the load.
All right. So we'll go and add in, you can see right now, the blue line is the contribution from the battery. Right now we're at 16 kilowatts, as John mentioned. There's a green line at 0 right now. That's how much PV power we're pulling in. And that's what I'm going to change in steps. And so we're going to keep a close eye on those in the plot. So I just added in 5 kilowatts of PV power, and immediately you can see the plot change.
So in this case, we've dropped the battery's contribution by 5 kilowatts, which is good. So we're making lesser demands on the battery, and we're letting the sun make up the difference of 5 kilowatts.
You'll also notice at the top that the load has remained unchanged on the microgrid. We're still supplying the same load all day long. Regardless of change in any of the conditions for where we're getting the power from, the load always gets what it needs. At this point, we're actually getting more power from PV than we're getting from the battery. But we're still taking a combination of both to supply what the load needs. You ready for another step, John?
Step it up again.
Okay. Now at this point, we're almost entirely PV powered. You can see the green is down at about 15 kilowatts now, and the contribution from the battery is only about 1 kilowatt. Again, the load conditions remain unchanged. Anybody sitting out on the microgrid is completely unaware of how we're mixing the sources of the power.
Now we call this means of operation a soft power limit. So even if there's more sun than we want, we ask for less sun and the system will go shut that sun down. So if the battery were completely charged and the loads were light, we wouldn't want to dump all that excess energy into the battery, overcharging it. So we manipulate this soft power limit to follow the load in real time, and that's what Mike is doing. So he's inching up the sun's contribution, inching down the battery's contribution, and this next step we're going to actually flip the battery around. We're going to power the microgrid completely from the sun, and we're going to start charging the battery.
With excess PV.
With excess solar power. And in this case, what you'll note is a sign change in the battery. As we started, we were discharging the battery at 16, then 11, then 6, then 0 or -1, and now we're in a +4 or +5 range. So we're actually charging the battery and powering the grid. This might be an activity that we do 3 or 4 hours a day in one of these microgrids so that we top the batteries up. We want the batteries charged but not overcharged, not undercharged. And then when they reach a high state of charge, what we want to do is we want to move to almost a trickle level of energy. And this will take a little work on Mike's half, but what we're going to do is we're going to take the solar contribution and have it exactly match the load. And when they're matched, the battery's out of the loop. And yeah, you're pretty much there now. So we've dropped the battery contribution to almost 0. And in fact,
every now and then you can see it go back and forth, the sign changing.
Yeah. So the sign is changing. So the battery is essentially idling along, not making any demands of the battery. Now, should a cloud pass over and the solar drops down, then the battery jumps right in and supports the load so that there's no disruption to the customers we're serving with the microgrid.
There you go, John. If you look closely right here, you can see the contribution from the battery. Occasionally it's positive, occasionally it's negative. It's actually going back and forth. We're stealing a little from the battery, we're pushing it back, depending on what's needed.
Thanks for your time today. We really appreciate you dialing into this microgrid demo. Please contact us if you have any additional questions regarding our products or technology, and have a great day.